Hi, I'm Amy Parsons, president of Colorado State University and host of the Next 150 podcast. We have so many remarkable people in our community, and this is where we're going to hear their stories. We're going to get their perspectives on CSU's next 150 years and gather their very best advice for today's CSU students. Let's get started, Rams. Well, hello everyone, and welcome back to another episode of the Next 150. Today we have the Department of Microbiology, Immunology, and Pathology duo, Dr. Karen Dobos and Dr. Marcela Henao here with us today. Dr. Dobos and Dr. Henao are the co-directors of the Mycobacteria Research Laboratories within our College of Veterinary Medicine and Biomedical Sciences, and they are experts in tuberculosis research, which is the topic of discussion today. Thank you both for being here.
Thank you.
Very happy to be here.
Yeah, so this episode is timely for multiple reasons. First of all, tuberculosis has been in the news lately because there's been an outbreak in Kansas City, Missouri, which is highly unusual, right? Tell us about what's going on there. I've been researching it a little bit myself, more than 67 cases.
Yeah, there's more than 150 cases and 67 people with disease. The rest of the people have the infection, but they don't have any symptoms. But it's still pretty significant. And the cause and why is still relatively unknown. Have you?
No, yeah. Still don't know.
But we do know predominantly in the counties surrounding Kansas City.
Yeah.
Other than that, we haven't been given a lot of information, to be honest.
Yeah, really unusual, right, to have that in the U.S.
It is very unusual, specifically in the United States, correct? Because we have a very low incidence in the United States compared to other countries, correct? While we see here 1 to 2 cases per 100,000 individuals, in countries with high incidence, we can see 200 or 500 per 100,000 individuals. But it's been something that it's probably happening also due to the pandemic, correct? Because the pandemic led to a lot of cases not being diagnosed, treatment not being done correctly. So it is being the increase in incidence has been seen in the United States and in other countries as well. It's actually worldwide.
Well, it's also notable because in March, it's World Tuberculosis Day. So an opportunity to bring a lot of attention to tuberculosis, and people are paying attention to it right now anyway because of this outbreak in the United States. So talk to me a little bit about World Tuberculosis Day and how you use that day to bring awareness.
Yeah, that's been a very exciting opportunity for us. World Tuberculosis Day is March 24th, and that's when the announcement was made that the disease was caused by this bacterium. We use it as an opportunity to perform outreach activities and engage with the high school community in Fort Collins and the surrounding area. It started very small, maybe 11 students, I think, in 2012, and it has grown exponentially ever since. I have some relics.
Oh, let's see it.
We decided to start making T-shirts.
Oh, great.
And so we made a kind of an eye-catching red T-shirt from 2013. And then we went with like a very bland.
Very CSU green.
Very CSU green.
Yeah,
and then we went
very on brand.
Official CSU green. And this is our prevailing shirt. And we actually have tuberculosis, having some fun in Colorado, doing some of the activities. That,
that's tuberculosis skiing and performing science and riding a bike.
Yeah,
I
doing
see.
all kinds of things. So just to try to get high school students excited about the amazing research programs that we have here. And I brought these in case you wanted any of these lovely T-shirts for yourself.
I love it. Yes, I love the relics. Yeah, we can put them right back there. Thank you. And what else do you have there? You've also got a book.
Well,
Let's talk about that.
We're a little lucky that John Green, who's a very popular writer for young adults, he was researching another book, and he got to know a boy named Henry. He thought Henry was a little boy, but he was a grown man with multiply drug-resistant TB, and that inspired him to write a book about tuberculosis, a nonfiction book. It came out yesterday.
Oh.
And what's really exciting is that because it's written for young audiences, I'm really hoping that more young people come into our field and come, do research, especially if they can do research at Colorado State. Yes. We constantly need new scientists because it is a centuries-old problem that, more young minds and and inventive opportunities is the way we're going to combat the disease. So it's
Amazing.
a signed copy. I also wanted to share it with
thank
you.
you.
It's a very fast read. It's very nice.
Well, it's called
actually.
Everything is Tuberculosis, the History and Persistence of Our Deadliest Infection. And it's written for young people, you said.
It is.
Okay.
Yeah.
Well, that's great. I mean, I'm rather evangelical when I talk to young people about the importance of going to school at a research institution, specifically for the reasons that you mentioned, the opportunities to get into the labs. Almost no matter what you're going to study at CSU, you have the opportunity to engage in research, but especially if you're interested in infectious disease research and actually having the chance to participate in this cutting-edge, really important research as an undergraduate student is really unique. Tell me a little bit about how you each were inspired as young people to come into science and become scientists and work on infectious disease.
Ooh, I'll let you start.
Okay. So I'm originally from Colombia, South America, and I started going to a laboratory when I was in medical school. They were doing a little bit of research in immunology and a little bit of research in infectious diseases. And then when I finished medical school, I realized it is very difficult to treat many people. At the same time, it's very difficult to actually provide health care to people. So I started working in that laboratory, and I was very lucky, first of all, to learn a lot about how important the research is, how many people it can reach when you have something like a vaccine to be able to prevent a disease or medication that might treat a disease. So I got very in love with it and started working more of it, and I did a master's on it. And then when I was finishing my master's, I actually met Dr. Patrick Brennan. Mm-hmm. He came to visit Colombia in one of the meetings that we had there on tuberculosis. And he liked the work that we were doing there in tuberculosis. And then he kind of said, we love having people from around the world visiting us in the Mycobacteria Research Laboratories. And he said, apply, try to come here, send your CV, and that's what I did. And when I came here, I started working first in Dr. Ianorm's laboratory, mm-hmm. and I started doing research, and I realized I needed to learn a lot more about basic research, so I decided to do a PhD here with him.
Oh, okay.
And then that's how I started a little bit It is a lot, actually, trying to find a way to help more people. Mm-hmm. Because as a medical doctor, it was just one at a time, and I couldn't reach what I wanted as easily, I think. So that's kind of what I thought. With research, I could do better.
Mm-hmm. And you found that to be true?
I do. Sometimes you don't see it translated so easily. It takes a little bit longer and a lot of, I think, vision, passion, and I guess perseverance to be able to get to that stage. But when you understand the big scale of what we do in the lab and the impact that it can have, and when you see actually your students see that difference, correct? When they start and they don't see how things get translated, but they eventually, towards the end of their training, they see how important it is. I guess every of those transformations make you realize that you are doing it, and you are doing it for a big population, not just for one person. Mm-hmm. Mm-hmm. Yes.
That's great. How about your journey?
Well, I had a strong interest in wildlife biology, actually, mm-hmm. and diseases of wildlife. And in my undergraduate studies, I was working with multiple Division of Wildlife and research organizations on studying waterfowl and reptiles. And I became aware that there were a number of losses of wildlife habitat from different infectious diseases. And the one that kept coming up was mycobacteria. And I honestly didn't know whether it was a bacteria or a virus. I was, I knew I could tell a frog, different frogs apart and stuff. But it fascinated me. I was like, wait, this is the same thing that's able to kill off all these other species. And it just fascinated me. And one of the mentors said, well, you should continue on to Colorado State University if you want to, if you're really fascinated by this. And I thought it was, to be a veterinarian because I didn't know any better. And then once I started exploring the opportunities, I was super excited to come here to pursue my graduate studies, again, with that focus on all the different species that the genus that causes tuberculosis in humans causes a similar type of disease in, waterfowl, livestock, reptiles. I mean, I just thought if there could be impact that would prevent this disease in any one of these species, it would teach us about how to prevent the disease in multiple other species. And that's what really inspired me to come here, get my PhD, and then I went out to see the big world, to go other places and continue to do research. And there was no better place with the collaborations and the infrastructure and the capacity to really show impact, like Marcela was saying, other than to just come back here and continue to contribute and try our best to stamp out TB.
Yep.
Yeah, we've both mentioned it a little bit, but CSU has a really remarkable history when it comes to this type of research, and now we're home to the largest group of university researchers in the world, right, doing work in this area on diseases caused by mycobacteria, chiefly TB, but also leprosy, right?
Leprosy and emerging mycobacterial infections called non-tuberculous mycobacteria that have a terrible impact in humans and animals.
Yeah, those are typically environmental mycobacteria, or they are not typically, they are environmental mycobacteria, but some of them have become also pathogenic for humans. And they actually cause disease in individuals that might have some immunosuppressions, or some people that might have like diseases like cystic fibrosis. The problem with these ones is that they are even more drug resistant than tuberculosis, which is very difficult to treat. So because the entire group, the entire 16 faculty members that we currently are in the group knew, and some of them already were working with non-tuberculosis mycobacteria, we've also started doing research in this area recently.
Yeah, and that includes complementing some of that research with, again, research in endangered species or threatened species, marine animals that are susceptible to mycobacterial diseases.
Wow.
There's a brand new mycobacterium called Mycobacterium mungi that infects mongoose. We're not aware of how it emerged, or we can't even really culture it in the lab like leprae.
How do you discover something like that in the first place, that it exists?
Honestly, it baffles me how much discovery went on prior to knowing genome sequences and having access to different DNA sequences. Yeah. Now that we have that global access, that research sharing, it's a lot easier to say, oh, this lines up with something we know. And then you can explore how similar or different it is. So that's how those advances are made so quickly now. But
wow,
how they were made
before
the 1990s, I just
honestly,
yeah.
So do you feel like the pace of change and research continues to accelerate in this area because of that sharing worldwide?
Yes,
drastically,
absolutely.
Yes. Yeah, I'm just curious. What does that look like to you in just working with researchers around the world? I mean, on like a normal day-to-day basis, how does that network develop and how do you work together?
Well, fortunately, because of the name and the amount of collaborations that our predecessors and the ones that right now are here, we all have a lot of collaborations. So typically, any of us would have a meeting with someone in South Africa, someone in South America. We might have a meeting with someone in England, because we have projects with people in all of those places going on. So that is very, that really makes us, I think, there are many groups that do tuberculosis and are similar, but it makes us very unique because we are too many of us, correct, and we are widely connected. And then we also have resources. I think you should talk about the resources that CSU shares with the world.
Yeah, we share a lot of resources and reagents globally. I mean, the impact is... Honestly, we stopped counting. We got to, I think, 48 countries and over 600 investigators that we've shared resources with, that it just was not believable. It was almost like we were making stuff up. But it's true. The Mycobacteria Research Labs are highly collaborative, and because of that, we are engaged on an international level. sometimes our days will start at 5 or 6 o'clock in the morning to accommodate other
Time zones.
zones. And then if we have a meeting at 3 p.m., we might get a little sleepy sometimes.
Yeah.
So,
well, at CSU, it's gone back to the 1980s, right? I mean, you mentioned a couple of the people who started it, Dr. Ian Orm, right, and Dr. Brennan, who started this in the 1980s. And that's how CSU is so world-renowned in this area today and doing all of this amazing research. It's really a remarkable place to be. And I imagine that it is for you all as well to be spending your careers here doing this research at CSU.
yeah, no, it is quite phenomenal. I mean, there's good days and bad days, right?
Yeah.
But I think the one thing that always gives me optimism and probably gives you optimism is that we're surrounded by people that we can talk to and share our research with, and obviously educate younger people. And with their ability to integrate with machine learning.
Yeah.
A lot of times I think they're teaching us a lot at this point. They're just
That's wonderful.
yeah, which is really, really exciting.
That might be the answer. I was just going to ask you sort of what's the leading edge in your laboratories today, what you're working on. Is it machine learning? Is it AI and incorporating that into your research?
We are incorporating some AI in the analysis of the data, maybe more towards the analysis of the data and in helping us deal a little bit with the big data analysis that we have nowadays, because it's becoming complicated just to be able to bring together the amounts of data that we are generating nowadays.
Yeah.
So I do think that every advance in general helps science. Sometimes it takes a little bit a while for us to be able to realize what would be the best way to do it, so that we are not actually bringing anything that is going to make things more confusing or is going to change the data in any way. But we definitely find that it helps us, correct? Because it has the power that none of our brains is ever going to have, correct? So that we do use, and the good thing is that all these very talented young minds are bringing to us, and that's something that we welcome
for them.
Yes, yes. And I think we're very open to it. We are passionate about what we are doing, so whatever makes it better, I think we're always open to it.
Yeah.
I mean, all the research we collect, with all of its fancy names, at the end of the day, it's the resolution that's greater. I mean, you look at even film, originally it was just this monochrome image, and what it was what it was, and there was no depth to it. And now that same image captured on our cameras is the resolution underneath it. All the little pixels are just thousands and thousands of folds more complex. And that's exactly what our data does, whether it's data on cells or data on molecules. It is, the depth of it is just deep, wow, crazy, And so, how do you harness that? Like Marcela was saying, your brain can see what it sees and knows what it knows, but everything underneath, you need some help and some power to interpret that and understand it and actually tell a story about it that's accurate.
How you use all of that information to move the field forward. I mean, what's most exciting to you in this field right now, just in terms of advances in either prevention or treatment?
Well, for me, it used to be considered that TB was two phases. Like you got infected and then you were okay, or you had active disease and needed medical care. And the field has now accepted the fact that this is a huge spectrum of disease, very complicated, and that people are very dynamic. And so one person with an infection is going to look dynamically different from the person sitting next to them. And so for me, what's exciting is the ability to have that appreciated by medical practitioners, policymakers, and ministers of health, so that we can actually try to understand and get markers that say, okay, these two people look perfectly healthy. We need to make sure that this person gets on antibiotics right away because they're going to get sicker, and this person is never going to even know they had the disease. And so that's really exciting to me to be able to tease that apart from my point of view. And then
definitely with your biomarkers. And I think for what I what we do most in the lab is it's how close we are to having another vaccine against tuberculosis, correct? So the vaccine development for tuberculosis has been extremely slow, sadly, compared to others like SARS vaccine development. So we have several vaccines now, many of them who were tested like many years ago here at CSU initially, or were also tested at CSU initially, that are now in phase 3 trials, correct, in human, of course, patients or individuals, I should say. And that's very exciting because it's the only vaccine after BCG that has more than 100 years, correct, that we are going to have available against tuberculosis. And it's not just having more vaccines available, it's actually that humanity has learned that we can have more vaccines, what is the path to developing more vaccines against tuberculosis, and how can we deploy them to the world, correct? Because we work with a lot of vaccines, and just having one or two more would teach us a lot more about which ones are better, which ones are not, so that we can keep that path. So that's one of the most, I would say, fascinating or exciting things that is happening right now.
Knowing that I was going to talk to you two today, I've been studying on tuberculosis a little bit myself. And I read that in 2023, 1.25 million people died of tuberculosis globally. And it looks in just my research that where that's really happening in the world are very populated, densely populated areas, and India, China, North Africa, places like that. What's driving the numbers in those particular areas around the country where we see the highest rate of tuberculosis and mortality? Is it lack of access to things like vaccines?
TB is a disease of poverty. It's a disease of racism. It's a disease of health inequities. That's where the opportunity for the disease exists. And that explains why we even see TB in the United States of America. If you look at the people that succumb to these horrific outbreaks, it's persons in those lower areas of socioeconomic development, even here. And so that's, wherever that's more congested, there's going to be more opportunity for disease.
And it's also definitely more populated areas where there are more people living in small spaces. The BCG vaccine that we don't have here, or that we don't use here in the United States, is used in those countries, correct? And we know that the BCG vaccine might prevent against disseminated types of disease and even some pulmonary disease for 10 to 12 years until kids are 12 more or less 12 years of age. But after that, it doesn't really prevent as much. But one of the reasons is that actually we don't know that much about the diseases still. So actually with the advance of science, we are learning so much in the few past years about tuberculosis that probably will be able to do big changes that we've never been able to do in the past 100 years, correct? So besides that is also that they don't have access to healthcare, as you were saying, but also they don't have the same access to other types of treatment. So their general health is not as good. So those things are not helpful.
I read there's
either.
the high co-infection rate with HIV/AIDS as well, which is, that's to your point.
Yes.
Yeah. So, looking at the future of the disease, where you see it going and where you see the research and the development of prevention and treatment, where do you see this field of research going in the future? Near future or far future?
I think one thing that Marcela just pointed out is you get this protection from the vaccine called BCG from infants into adolescent. And then you start to see TB in adults in their 30s. And so the areas of focus were either babies or adults. And we were missing adolescents. And if you actually look at what population is transmitting the disease in areas where it's problematic, it is that adolescent population that's been largely ignored. And so I think for me what's exciting is being able to understand what's going on as people are developing into adults and becoming more social, and at the same time having this other vaccine not working as well, understanding what is going on in that and very, very important population of people and how that can be harnessed to achieve lifelong protection or better drug advancements. I think that's a really, really important area of research to look at.
That's fascinating.
I would also add to that with the development of the SARS or the COVID vaccine, we've also learned so much about how we can kind of teach the immune response in all humans to respond better against infections. So I feel the field of immunology has kind of exploded. Before SARS-CoV-2, my entire family didn't understand why I left medicine to do immunology. After SARS-CoV-2, they actually understood what I was doing. And it's very important because it's basically the way our body talks to infections or even to cancer and to many other things, correct? It's the way they try to respond to that. So I feel like the exponential understanding that we have on immunology is going to help us as researchers also fine-tune those responses in the best possible way and at specific times, as Karen was saying. Not just whenever we see the disease, but before we see the disease, correct? When we see biomarkers. So we kind of, based on the epidemiology that we know, based on the biomarkers that we can find, we can now find better or vaccines or ways of, for example, giving them some nutritional enhancements to some individuals or some adolescents so that they are not going to be so susceptible to the disease, correct? So I think it's very exciting to see how the connection of all the sciences that is happening and the exponential learning that we have in some aspects in science is going to help us kind of better treat it as a whole.
That is really exciting. All of that.
Yeah.
I mean,
Yeah.
it must be a really exciting time for you to be in this research. And I have to say, it must be an exciting time for students to be coming into this field right now, too, with all of this new information and all of these developments. I like to end all of these podcasts talking about students and the future. You know, students are our number one priority here. Talk just a little bit here at the end about how students get involved in your laboratories, what that experience is like for them, and maybe some advice for young people who want to be you someday and to come into this field and study the infectious disease.
Yeah, I mean, all of our labs, first of all of our labs have amazing opportunities. And there are a lot of high school programs that offer biotechnology certificates.
It's amazing.
And they can actually come into our labs over the summer and work towards their certification in high school, which promotes their ability to get into different undergraduate programs. We have multiple undergraduate research programs as well. We say that we're one of the largest in the world, and one of the reasons why is because every single one of our labs has undergraduate researchers, and multiple, and they're
5, 6.
They are an asset. I mean, they are an asset for us. This is a 24/7 disease, so it doesn't, it's not like a typical job where it's open from 10 to 6 and doesn't work with the student schedule. This one works with all schedules.
What terrific experience for the undergraduate students.
I think they also need to be, I think they should not be scared just to reach out. We typically are very excited when students come to us and they know a little bit about tuberculosis, because many people used to think that it didn't exist, correct? Right. So when a student comes to us and they say, I know tuberculosis, or someone else I knew had tuberculosis, or I knew an animal, or I know about lions that had tuberculosis, or an elephant, so they know a little bit about it, they really impress us. And the other thing is that it's not that easy, actually, that students want to do hard work in the labs. So we welcome students very often. There is a lot of different things. In our department, in microbiology, immunology, and pathology, we are actually very committed to have all our undergraduate students in our major to have an opportunity in our labs, correct? Because we want them to see what a research environment can give them. And it gives them not just the opportunity as they think to work, but it also gives them they learn to trust themselves. They learn to make mistakes, and we are very fine with that. We all made so many mistakes to come to where we are, of course. So we let them do mistakes. But they also make the environment of the lab, or they give the environment of the lab the energy that we need. correct? We like to have groups that nourish each other. And these young individuals that are full of energy is what we need, correct? So we are very open to their mistakes. We are open to the things that they bring to us. They have a knowledge that we don't have, correct? They have experience. They always have great ideas, correct, when they are not afraid to talk. And they do jobs at different times because they are very excited to do it as well. So I think it is just a matter of asking several times because sometimes we take a while to respond, but we really love having them in the labs.
And if I was going to say anything, I would say TB has changed the world. I mean, that's the truth. It's affected art, fashion, architecture, politics, public health. So it's very accepting of people with very diverse interests as well. And we need people with very diverse interests. Some of our best students have been anthropology majors.
Oh, really?
That have then crossed over into being, co-majoring in microbiology and anthropology. It's a disease of society. And so we need people that think about society and behaviors and interactions, that can actually look at, how do you improve health inequities if you can't get things delivered? Can you think about engineering, drone? I don't know. I don't know what I'm talking about.
Communications.
But can you get it on? Can you do social media to try to reduce the stigma and encourage participation?
Very important.
I mean, there's not a single facet of the world that will not benefit from having a diverse mindset in tackling this global problem.
Yes.
Well, that's what we have at CSU, a diverse mindset, right, of our students who are eager to solve global problems. And I learned so much in this conversation with you both today about how tuberculosis is everything and how our students can get involved. And I just want to thank you both for your work in this. It's making, obviously, a huge difference. And we're glad that you're here leading this way for the country, for the world, for Colorado State University, and the work that you do with tuberculosis research. It's really impressive. And I know that our students will really take your advice to heart and reach out and to be persistent and find ways to get into the labs and really make a difference and learn to trust themselves and apply what they know. Because, like I said, that's, I think, the most important thing about going to school at a big world-class research institution like CSU is to have those types of opportunities. So thank you for making those available to our students, and thanks for the work that you do.
Thank you.
Thanks for the time.
Thanks for being here today. Well, that's it, Rams. Thanks for another great episode of The Next 150.
Thank you for listening. I'm Amy Parsons, president of Colorado State University, and you're listening to CSU's The Next 150, where we explore what comes next for CSU by chatting with change makers who are already leading the charge and shaping our next 150 years. I'm gathering their very best advice for today's CSU students. Stay tuned to wherever you get podcasts for our next outstanding conversation. Go Rams!